When I was an infant, my grandmother used to show star clusters and teach me their names. I was fascinated by my star, Punarvasu, shining bright in the sky. Then I started to see the difference between it and the nearby star Tiruvadira. One is white and the other is red. I didn't know that I was learning the luminosity of the stars at that age. Now, when I look at the Hertzsprung-Russell diagram of the modern astronomers, I understand the educative process of the ancient Indian astronomers. Indians started in infancy itself. When the child is brought out of the house for the first time to see the moon, the mother asks, "Have you ever seen such a beautiful object?" I wonder whether the question was addressed to the moon or to the infant, probably to both. My grand uncle, the philosopher poet Nalapat Narayana Menon, used to say, if there are people who don't believe in God, let them just look at the stars and their rhythms. That is the sign of God. A man cannot do or produce that rhythm. Almost similar words were said by Vincent van Gogh. For my part, I know nothing with any certainty, but the sight of the stars make me dream. That was what he said. Astronomy means the measurement of stars, and astrology means the knowledge of the stars. Without measurement of stars, we can't understand the stars. Two terms interrelated but often mistaken, one as science and the other as non science, respectively. The study of astronomy had already evolved into cosmology and the origin and evolution of universe in India before the Vedic times. And when we read an astronomical text like Panchasiddhantika, we remember this. This was the defect which misled Thibault and other Western scientists when they tried to understand Indian astronomy in terms of Euclidean and Greek astronomy and their divinations. The cosmological distances were measured by Indians thousands of yugas before Hubble's constant. How do I state that? There are some methods described in Varahamihira. For the stars close to us, the best method is the combination of a parallax. Parallax is the shift, which is apparent change in position of star viewed from the earth at least for 1 year. At least you have to observe for 1 year to learn the parallax. And there is an esoteric technique, that is measurement of the moving clusters. And another method is to look for the redshift in the spectrum and analyze the light from the stars and galaxies. The redshift shows that the star or galaxy is speeding faster away from us in a cosmic distance ladder. Thus, our position, that is the Earth's position, is at the bottom, and the most distant galaxy will be at the top. Betelgeuse, that is the Tiruvadira, is thus a supergiant red, and Punarvasu is a white main sequence star. That is what I was learning in infancy. I didn't know that I am learning this, but I had understood that one is red and one is white. When the ancient astronomers say that the universe has already seen several yuga, kalpa, and is in the seventh manvantara of Varaha Kalpa, they mean that the age of the universe is that much. And when this idea was first heard, the 16th century European astronomers thought that it is only an illusionary, fantastic superstition of Indians. But now they are also saying the same thing. If HO is 70 per kilometer per second per megaparsec, the age of the Big Bang is 14 billion years, they say. They say that the expansion of universe will become slower and slower. Q0 as deceleration as time goes by. This is equivalent to saying that the Kali Yuga, which is fast, will become slower and slower and end up in a Satya Yuga again in a cyclical manner. We must remember that the modern scientists 3 lakhs years elapsed after Big Bang for the galaxies, clusters, superclusters of galaxies to be formed. Events and processes even long ago leave traces in the universe. About 30 lakhs, 40 lakhs years after Big Bang, the cosmos was permeated by sound waves. When Indian cosmology speaks about the Nada Brahma, the creation of sound and light as a mandala or field. It is this ancient period that they are talking about. With generalization of Newton's mechanics, the space-time near a massive object is found to be distorted by the object, and this produces a basic effect as a gravitational pull and orbits are produced. The observed universe is only a very, very tiny part, as Gargya says in his Gologa description in Garga Samhita. Varaha Mihira and the other Indian astronomers were aware of these cosmological proportions of Garga and their ancestors, and this is reflected in their astronomical texts. We must also recollect that the general relativity and Newton's mechanics give only slightly different results. Distortion of space has a consequence, which is very important. Light from an object directly behind another, more massive object can have its direction changed so that the object itself appears to the observer to be shifted from its real position. An extended object can have the image changed, called gravitational lensing. Anybody, any body with mass can lens only any other body. One body with mass can lens any other body. The path of light can be altered by dark matter. When slight distortion, it is weak lensing, the amount of solar energy falling on the surface reflected back to the space. Fractions between 0 to 1 is the value, and for Earth it is 0.39 or 39% of light is reflected back. This figure is roughly 1 nakshatravadhi or the star limit. The star limit is 39 to 40 in Indian systems. Another important matter I want to stress is that the MSL or mean sea level or surface level of sea horizontal to land, and its ellipsoidal nature due to spin can be understood only after several thousands of years of observation by people who live near the seashore. That is important, in the seashore, near the seashore. And this observation for several generations of people at the coastal area make them understand the random waves, the regular tides, the atmospherical air pressures, multi-year phenomena like tsunami, which come at regular intervals, the monsoon winds at regular intervals. And this is very important for any seafaring people. The sea trade of India is first mentioned in Rig Veda, which is the most ancient text, and hence the seafaring activity and observation of sky and wind might have started several thousand years before the Rig Veda was conceived. And hence, when Varahamihira speaks of star observations, heliacal risings of stars, the classification of comets, etc., we must know the antiquity of such intellectual activity, which is the unique heritage of India. It didn't start with Varahamihira. It is more ancient than Aryabhata. It is more ancient than even the Veda. The observation of monsoon, especially which is unique for the Indian coast, must be taken seriously because it will give you a clue to the fact about the mysterious Phoenicians who used the same script, the same techniques of shipbuilding that, and trade as the Indians and Vedic Ashwins. None of these things were considered by either Thibaut or by other European astronomers when they placed Indian astronomy as a meager offshoot of Greek astronomy. And so you see the modern historians also just repeating that mistake, just as a parrot do, to consider that the Riemannian sea landscape with infinite zeros at sea level from the point of view of the Indian subcontinent, the solution of Riemannian problem may become easy for the astronomers. That is just my suggestion only. The equator is a great circle. After 1600, we started to take Greenwich as mean time. But Greenwich is not at the equator. In India, Ganga is the closest landmass to the equator. And that was taken as the zero great circle. How scientific they are. The longitude, the meridional that crosses Lanka at right angles to it, passes through India. And this was the Indian standard time all over Lanka and India. Such a unified system was never known to Greece or Rome, and only after India became a British colony, Greenwich was established as zero because they came into contact with our knowledge. This clearly points to the fact that the West had been borrowing science from the East not only during the Greek time but also even in the 16th century British time. In 1884 only, the 15-degree steps of longitude and 24 one-hour time zones were accepted even at Greenwich. Think of it. Hence, the 24 hours of the 24 horas of India was known to Britain only after its contact with India, not with contact of Greece or Rome. They had been in contact with Greece and Rome for several centuries, but they didn't know this because the Greek didn't know this. The English translation of Thibaut, which came in 5 years after 1884, it came in 1889, and when Einstein was only a child of 10 years, is noteworthy. When English translation of Arahamiras Panchasiddhantika came, Einstein was just 10 years. But we find the E is equal to mc square ratio put in a mathematical way in that text. To mention a latitude from the pole, one has to mention the co-latitudes, the reference pole, whether from south or north, etc. And Varahamihira mentions that in his table, showing how scientific he is about the spherical stellar geometry of the cosmos. Modules of colatitudes are polar distances or the linear surface distance.